Hi guys, it's Mrs. Weeks, and just sadly Mrs. Weeks. Poor planning on my part meant I didn't have my partner with me to do this video, so I'm all alone. So I hope that I can be quick and spunky enough for you, but you know, I have to say, without my partner, it's a little hard. So, so sadly we missed Mrs. Poole, but we will go ahead. We're going to talk a little bit about adding and subtracting fractions, and we're going to take a look at when we have different denominators and we're adding and subtracting, or whether we have the same denominator and we're adding and subtracting. Two hard and fast rules for you that you need to put to memory for adding and subtracting fractions. First one is that they must have the same denominator in order to add and subtract. The second thing you need to remember is you never add and subtract denominators, okay? So once you find those same ones, or if they already have the same, you just never subtract them and never add them, okay? So let's talk about the problem we have here in front of us. We have 2/5 and 3/10. Right off the bat, I do notice that I have unlike denominators. So I'm going to have to do some figuring out here. I've drawn kind of a rectangular down here because I thought maybe I could do a model and show you all. Oh, now I'm moving the model. That does not work at all. All right, let's see if we can get this. See, I don't have my partner. This is what happens. Okay, so the first thing I'm going to do is I'm going to break this in half, because on one side, I'm going to put 3/10, and on the other side, I'm going to show 2/5, okay? Well, tenths are pretty easy. Okay, and you have to forgive me. Remember, we're not perfect when we're doing this. So, and then fifths. All right, I think I got them there. So, all right, this one kind of lends itself nicely to a model, because right off the bat, some of you may notice what I did, and that is that these fifths actually represent 2 of the tenths. See this? The way they take up two spaces equal 1 of these. Okay, so right off the bat, we can kind of see how easily 5 and 10 sort of lend themselves to each other, and how I actually could turn these 2/5 and 3/10. So I could do 1, 2, 3 of these plus 2 of those. Now the thing you have to keep in mind is 2 of those fifths, you'll notice, because remember we have to be dealing in the same denominators, you'll notice that they sort of equal 4 of those. So it would actually be like saying 1, 2, 3, 4, 5, 6, 7. So what I can see is that these would actually equal 7/10. So mathematically, some of you are going to see that I easily could turn this 5 into a 10, because a multiple of 5 is, of course, 10, and that this model nicely lended itself to changing those fifths into tenths. So you can kind of see how I came up with my 1, 2, 3, 4, 5, 6, 7 tenths. Okay. Now that's a model, and that works if you're going to have a simpler one that kind of lends itself to doing that. A little bit harder if you have a more challenging problem that you don't know how to split up those tops and bottoms and how they can kind of coexist together, okay? All right, let's take a look at the next one that I have for you. Now this is if I have like denominators and what these models are going to look like. This is very important because we actually will have times, especially on your test, where they'll show you what a model looks like, okay, for this. So in this case, I have fifths, okay, and we're starting with 2 of those fifths, so it might show you something like this, 1, 2, except we're adding on another fifth, and you guys practiced this in class, which was great. So in order to show that in a model, we would show it by either coloring it different or showing some way that you actually added on. So 2/5 plus 1/5 then would be 3/5. And again, because these have matching denominators, this is a gift. This is nice and easy for you, so it's really not as difficult, okay? All right, how about this next one over here is 3/4 minus 2/4. This model looks a little different, okay, because we're not dealing with something that is being added on. We're actually taking away from what we started with. So in this case, we have fourths, and what we started with was actually 3 of those 4. So I have 1, 2, 3. Oh, how nice is that. Now I'm not going to need another color necessarily, because all I'm going to do here is now I have to take 2 of those away. So what I'm going to do in my model is I'm actually going to X out 2 of them, because I'm taking away from what I started with, which was 3/4, and I'm taking away 2/4, which leaves me with 1/4. Okay, and I just want you to see that, because that will be a model that you need to be able to identify. Okay, all right, next we have is where we have a situation where we have 2/3 plus 3/8. Okay, and again, these are different denominators. And so you're thinking to yourself, what do I do with these? Okay, well, the truth is you need to find a way for them to be the same. Remember, we're not adding them. There's no way this should be 5/11 or anything like that. So please don't ever do that. We've got to find matching denominators. One way you can do it is called least common multiple. And we did this when we were comparing fractions. Great thing to have in your back pocket also for adding and subtracting fractions, okay? So in this case, I'm going to put 3 and I'm going to put 8, and we're going to list out these multiples and see if we can't find one that matches. So 3, 6, 9, 12, 15, 18, 21, 24. Okay, I'm going to stop there. Okay, and then I'm going to do 8, 16. Ooh, look at that. Okay, I'm going to stop right there. The reason I stopped is because I did notice that I have a common multiple, and that's 24. So what I need to do now is I need to change these 2 fractions, and I need to turn them into 24ths, okay? So I'm actually going to erase these little arrows so that I can change these into 24ths, okay? All right. So I have to change this 8 into a 24 and this 3 into a 24. So how do I do that? Well, how do I make an 8 into a 24? Well, I do that by multiplying times 3. And remember, whatever I do to 1, the denominator, I must do to the numerator. So we're going to multiply this times 3 too. This becomes 9 24ths. Now let's look over here. What did I do to make a 3 into a 24? Well, in this case, I multiplied times 8. And again, if I'm going to do it to the denominator, I must change that numerator. Okay, because the size of the pieces changed when I did them into 24ths. So it can't be 2 pieces of 24. There were 2 pieces of thirds. We got to make a bunch of other pieces there. So this becomes 16 24ths. All right, well, now I've got to do my math. So what is 16 plus 9 is going to give me, and remember, do I do anything to do these 24ths? Okay, I don't do anything to them. Good job. I'm sure you gave me that answer, right? Uh-oh, well, something's going to happen here, and maybe you all have already figured it out, but what's going to happen is I'm going to end up with 25 24ths. Oh, the horror. Well, what do we call this kind of fraction? You all should know this because we just did this. This is actually called an improper fraction, where the numerator is larger than the denominator. And no, I didn't mean for this to happen, but since it has, it's not a bad idea. Okay, so let's see what we can do. How many times does 24 go into 25? We ask ourselves, well, it only fits 1 time. And what's going to be left over? Well, 1 24th. Okay, and that is actually what our answer is going to be. So 25 24ths or 1 and 1 24th, okay? All right, guys, I'm giving you some homework here. So we have 2 problems. The first one is 2/4 plus 1/6. The second problem is 3/5 plus 1/3. Please bring these in tomorrow worked out. Remember, you have some things that you can do in order to help you. Either models or things like that you could do. But mostly I really do want you to work on that LCM and see if you can find some common multiples that you could make into a common denominator. Okay, very important. Okay, all right guys, have a great evening. We miss you, Miss Poole. Bye.